dun, dun. Dun, 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 dun. Hooray! Hola! Hey, Mr. War here. Welcome. Thank you for joining me in this wonderful world of math. Yes. Matemáticas para ti. It's math time. Let's go ahead and get started. Why we got this screen? Is it trying to hide something? What are you hiding there, huh? Let me say. What are you hiding? Ah! Oh, it's just a bear, you guys. It's kind of a scary bear. Let's not ponder unless you know what we could do? Let's make him a mini bear. Like, mini, like mini me. Let me see. Woo! Oh, he's less intimidating now, isn't he? Turn him into a black speck. Ooh, he's a little clump of something there. Anyway, this is chapter 7, in case you were wondering. It does say chapter 7 there. What do we have here? It says Mrs. Williams is organizing her office supplies. There are 3 open boxes of paper clips in her desk drawer. Wouldn't you know? Each box has 7/8 of the paper clips remaining. How many boxes of paper clips are left? Okay. Shade the model and complete the calculations below to show how you found your answer. Okie dokie. So each circle kind of represents one of the boxes, and if it says each box has 7/8, since I see 1, 2, 3, let me check. I got my magic pen so I can make a mess. Yeah. Okay, so that means there's 8. Mr. Warwick, calm down. Okay, so there's 8 in each box. I'm supposed to have 7/8, so that means they have 7. Let me see what I can do here with this little blue dot over here. This be able to help out. Ooh, it's Pac-Man. It's a blue Pac-Man. You're too big. Get small. Oh, look at that. Does that just fit really nice or what? I'm telling you. Make it a little bit larger there. So that looks like 7/8. 8/8 makes 1 whole. 7/8, 7/8. We have 3 boxes with 7/8. Cool. 3 times 7/8 is going to equal then 3 times 7 is 21/8. Now, of course, that's going to equal. Let's put this in a mixed number form. Let's see, 8 will go into 21, 3. Nope, not quite. 2 times only. Ooh, with a lot left over. 2 times is 16. That means 5 left over. Diana worked on her science project for 5 1/3 hours. Gabe worked on his science project for 1 1/4 times as long as Diana. And of course, Paula worked on her science project 3/4 times as long as Diana. For numbers 2A through 2D, select true or false for each statement. Now, I know some of you are going to want to rush really fast just so you can answer the question, but let's slow it down. Yes, let's slow it down. If she worked on her project this long, at least it gives us an idea, 5 1/3 hours. Where it gets tricky is where we say Gabe worked on his science project 1 1/4 times as long as Diana. Well, the first question I would ask myself, does that mean that Gabe worked on it longer or less or the same as Diana? Does that give us that information? And of course it does, because if we were to actually take 5 1/3 and we were to multiply that by 1 1/4, I think what you're going to find out is that we can turn this into those fractions greater than 1, or improper fractions, as I like to say. And here we have 5/4. And look at that. You end up with 80 over 12. Now, if we divide out 2, could we divide out, well, at least, no, I can't do an 8. Let's just do the 2, which will make that 40. We divide out a 2 here, we get 6. Yeah, we do have another one, 20 over 3. And 20 over 3 is the same as 6 2/3. So you can see by just that, we know that Gabe worked longer. 6 2/3. Sorry, that's a 2. Now it says Paula worked on her science project 3/4 times. Now if you recall in a previous video, 3/4 times, well, that's less than 1. So that lets us know that Paula worked on her science project less time than did Diana. So that's good to know. So we know it's going to be less. Let's see if we really have to figure that out, because these are true and false questions, and we might not need to do the calculation. It says Diana worked longer on her science project than Gabe worked on his science project. We just determined no, that is not true. Falso, as we say in Spanish, or just false. That's not true. Not true. Now it says Paula worked less, keyword, on her science project than Diana worked on her science project. Remember, by just looking at that 3/4 times, We know it's less, my friends, because if it was 1 times, then it would be exactly the same. And since 3/4 is less than 1, we know it has to be less. So, of course, this is a true statement. So we're going to go ahead and put true. Isn't this fun? Yeah. Okay, Gabe worked longer on his science project than Paula worked on her science project. Okay, well, that was also true. That's what we determined. This is almost the, oh, wait, no, this is not the opposite. This is Paula. Excuse me, I was rushing through this. I forgot we do have 3 people here. So if Gabe worked longer than Diana, which we established, and if Paula worked less than Diana, which was this one previous, right, that we did, then obviously Gabe worked longer on his than Paula. See that? It just kind of makes logical sense. And now we have Gabe worked longer on his science project than Diana and Paula combined. Well, that seems kind of hard to believe. It really does. And, maybe I should just check and make sure. Okay, let me add Diana's time with Paula's time, and we'll just find out. Diana worked, what did we determine it was, 6? No. Oh, 5 1/3. That's the one that was given to us. Okay, just ignore that little red, little kind of weird looking parenthesis thing there. Okay, it's gone. Now I'm going to get back to my red. Okay, come on, red. So 5 1/3, and then Paula was 3/4 time. We never did figure out what hers was. 3/4 times as much as Diana. So again, we're taking that 5. Well, let's just go ahead and multiply that then by 3/4. Let's see what we get. We still get our 16/3 here, times 3/4. Of course, now we're getting 48 over 12. 48 divided by 12. I like that one. That's 4. Exactly 4. So here's Diana's time. Okay, I'm not trying to do any trickery with you guys. It's right there. And, of course, then that means that's 4 hours. So if we were to add 4 hours and we're at 5 1/3, is that going to be less than Gabe's time of, did we get Gabe's time? We did, didn't we? 6 2/3? No. So this one here, clearly false. And we probably could have guessed at that one, but I don't like to guess. I like when I can figure out my answer. That is one of the mathematical practices. I don't know what number it is, but it's one of them. Mathematical practice 6, possibly, where you look for your reasonableness of answers. So, you can kind of do some careful work here. Now, let's look at number 3. Man, we're just cruising. It says, Lois wants to carpet the rectangular floor of his basement. Okay. The basement has an area of 864 square feet. Okay. What I like to do right away, I should probably read the whole problem first. Oops. But I'm going to go ahead and draw my rectangular floor. And I'm just going to put my 864 square feet. Just want to have that there. Now, I feel better. The width of the basement is 2/3 its length. Okay. So if this is the length, and if it's width, it's saying it's 2/3 its length. Okay, that's like saying 2/3 L, because that's 2/3 of L. So we'll say 2/3 times L. What is the length of Lewis's basement? Ooh. Now this is a doozy of a problem. A doozy, my friends. At least that's what we used to say in my time. Quite some time ago, I might add. Sorry, that black dot was bothering me. Okay. Well, honestly, the way to solve this problem would be to actually multiply the L, but you'd have to square L, and that's not 5th grade. Not right now, anyway. And so that would make it really confusing. So looking at this, I'm kind of wondering why this problem is in here. Maybe this was a lesson that we weren't required to do via our school district. I'm going to say then the only other thing you could do is maybe you could do like a guess and check kind of thing. So like, think of it this way. If we have 864 square feet, that means these two numbers here were multiplied with each other to give us that 864. Well, let's just try a weird number like 20 times 20 is 400. All right. So if this was 20, and then this is 2/3 of that, so that's going to be a little bit less than 20. Remember, 2/3 times, so it's going to make it a little bit less. So that means we would have 20 times less than 2,400, so it's definitely not 20. So I'm just clearly doing I don't know what you call it, trial and error, guess and check, something like that. So if I did 30, well, 30 times 30 would be 900. Ooh, okay, now we're getting in the right ballpark. See what I'm saying? And I don't even play baseball. So let's try 30 then. So let's make L 30 for this problem. Okay, and why don't I have a pen? Thank you. I need a pen. Thank you. Let's get blue. So let's just say that L is equal to 30. Oh, blue, so calming. And here we have 30. So let's put our 30 down. Okay, 30. Now we have to take that times 2/3, right? And then really what we're doing here is saying 2/3 times 30. This is this right here. And then I guess we could also multiply by another 30. Does that make sense to you? Because the area here in this problem, let me simplify, is length times width. But we don't know what the width is, but they're comparing the width with the length. So we're just going to say instead, just right up here, it's just actually length times 2/3 times L. That's going to give us our 864. So let me do this part. Whoo, associative property. Let me do this part first, and then I'm going to multiply it by another 30. So if I multiply that across, you can see that's pretty easy. That's 60, and that's going to be over 3. Well, that's kind of nice. 60 divided by 3, 20. Okay, so we'll put 20. Now I'm going to go ahead and multiply it by another 30. Let's see what I get. Ooh, I get 600. And that's going to leave us short. So we know that length can't be 30. So this is all about trial and error. So that's trial and error number 1. Well, let's try another one. Rather than using 30, goodbye, let's just go up to 35. Let's see what happens. And we might have to go back down again. Who knows? 35, let's do the exact same thing we did, times 2/3 is going to equal 35 double those. That's always nice. That's 70. And then 70 divided by 3. Oh, let me tell you right now, that is going to get really, really ugly. Okay, 70 is not divisible by 3. Not good. So I'm going to say, you know what? Because I know that 36 is divisible by 3, I'm going to change my 35, and I'm just going to change it to a 36. All right, so goodbye 5. Okay, goodbye 70. And, ooh, pinpoint accuracy. Almost had it. Now I get my blue again. Blue on blue. Dun, dun, dun. Okay, so this is going to be 36 then. Now 36 double, those are nice. That's 72. Yeah, 72. If you add 7 plus 2, that's 9. That means that this whole number is divisible by 3 because 9 is divisible by 3. That is called the divisibility rule for 3. So 72 divided by 3 then is equal to, if you break that into thirds, you're going to get 24. So 24, 24, 24. All right, so I'm going to put 24. Now we still need to multiply that other L, which we said, remember we changed our answer now, we said it was 36, so I'm going to change that. So now we're going to take that times 36. So now, ooh, this isn't really friendly. But what we could do is we could do the distributive property, or we could show multiplication straight out. And I think I'm actually going to show you straight out because this is a skill you guys need to know how to do. Okay, the algorithm. We always multiply in the ones place first. 6 times 4 is 24. So we have to put the 4 down here and we carry the 2. Remember, the 2 is going to get added later. Now we go from the ones to the tens place over here. We have 6 times 2, which is 12, plus 2, which is 14. Like it so far? I like it. Okay, so now I need to put my placeholder in there because I'm going into the tens place. So I need to make sure this stays in the tens. 3 times 4, now I'm going the opposite direction, is 12. So I have to put the 2 down there. I carry the 1. Remember, I'm going to add that later. And now the last column here is 3 times 2, which is 6, plus 1, which is 7. Do you like? Oh, look at that, my friends. Is that the thing I love about math? Yes. It comes to 864. It's exactly what we need. So we had to do a guess and check, and we got it. And I think that was a pretty hard problem, you guys. We spent a lot of time on it, but okay, it's done. All right, let's move on. What do we have here? Franny put 2/3 of her music collection on an MP3 player. Do we even use those anymore? Yeah, I still, a little bit. Not too often, though. It says, while on vacation, she listened to 3/5 of the music on the player. Boy, this is really, have to simplify this problem. We're going to reread this again. Ooh, definitely. RDW. How much of Franny's music collection did she listen to while on vacation? Of course, this is for numbers 4A through 4D. Choose the correct values to describe how to solve the problem. Okay, well, she has 2/3 of her music collection. So just kind of think of it. She's got her music collection, is all this, and let's just make some thirds. We're just kind of doing this quickly. So basically what she's saying, she has all this music, but she's only going to take this much of it and put it on her MP3 player. So 1/3 of it is going to stay home. Sorry. Now it says while on vacation, she listened to 3/5. So she actually listened to 3/5 of that 2/3. And that, my friends, should sound like multiplication. So this is why we're going to follow this using a rectangular array. It says draw a rectangular array with 3 rows and 5 columns. Now, as you can see, I have some of these ready for me. So I'm going to go ahead and do it this way. I'm going to put it in a rectangular. I'm actually going to put it in a rectangle. Okay, I'm not sure this is what they wanted us to do, but it is what I'm going to do. Okay. Now, it also says I need to have some columns. So how many columns? Well, since we need to get fifths, that tells me I need 5 equal pieces. So I'm going to do something like this maybe. And we'll see how close I get to it being fifths. As you can plainly see. So what am I going to have here? I'm going to have 3 rows, and obviously I'm going to have 5 columns because you can see 1, 2, 3, 4, 5. And here's my 3 rows. Yes. Now it says shade. Ooh, I made a mess. I have to do more work. Shade so many blank of the rows gray. Yeah. So I'm going to do this row here, and I'm liking it. And then, of course, I need to circle 2 because I did do 2 of the rows. That's right up here out of the 3 rows. And then finally it says Franny, or it's a shade blank of the gray squares black. Okay. Oh, it says how many squares black. Okay, so I did do my 6 squares, so we're good. So that's why it should be 6. Come on, 6. Thank you. So we're saying then we have 6 out of 15 then. And we can actually divide out a common factor of 3, giving us a brand new equivalent fraction, which will be 2/5. Now, as you can see, there it is, 2/5. Voila, yay! Now, we have Logan bought 15 balloons. 4/5 of the balloons are purple. How many of the balloons are purple? Draw a model to show how you found your answer. Okay, well, this is nice. Let's do, since we're looking at fifths, and we're going to be looking at making the row, I would say probably the easiest thing is just go 5 across, since we need to make fifths anyway. That means each column could represent 1/5, 2/5, 3/5, right? And now this is only 5 balloons, so I know I have to come down to make another row. 3 rows and 5 columns. Now I have my 15. And looking at this, I'm thinking 4/5. It says 4/5 of them are purple. Well, I'll use a purple line. How about that? 4/5 of them. Well, here's 1, 2, 3, 4. My goodness, it's all of these right here are actually purple. And this little dot represents means that they're purple. Okay, oop, he got 2 dots. All right, so we have 3, 6, 9, 12. So there are 12 purple balloons. All right, I'm going to keep going. Kayla walks 3 2/5 miles each day. Which of the following statements correctly describe how far she walks? Mark all that apply. Okay, you know how the smarter balance, they love to give you questions like this. It's not like the old days where it's like you knew one answer had to be correct and the rest were wrong. No, welcome to the new world of math, where Common Core says, well, there could be more than one, because they really want you to critically think these problems out. All right, let's do that. So we have 3 2/5 is an important number because that's what Kayla walks each day. So Kayla walks 14 2/5 miles in 4 days. Okay, that's what she does in 1 day. I'm trying to think if I could figure this out in my head. 3, 6, 9, 12. Ooh, that's pretty close. So I think what I'm going to have to do is, how do we do that? Well, we need to turn this into that number, a fraction greater than 1, or what I like to call an improper fraction. We do that by multiplying the whole part and the denominator, which gives us 15, and then we add the numerator, which gives us 17. Nothing tricky. Okay, over 5, and I put times 4. Now, I like to, like you guys know, I like to cancel, if I can, to divide out a common factor, but there are none. 5 and 4 do not have a common factor, so I'm going to multiply across. 17 times 4, 8, 2, what is that, 68 over 5. Well, I need to put that back into a mixed number because that's what they have here. 5 goes into 68, Ooh, lots of times. 10 times, 11 times, 12 times is 60. 12, 13 times would be 65. So 13 and 3/5. Does that sound right? I would have to say, not to get back, that's how I could do it. 15, yep, 65, 68. Looks good. However, it does not look good here. So that does not apply. It was close, though, but not quite. Okie dokie. So now let's look at the next one. Kayla walks 23 and 4/5 miles in 7 days. So again, if this were to be true, we should be able to take the 3 and 2/5, multiply it by 7, like we did on that last one, and let's see if that will be true. Again, I'm going to turn this into a fraction greater than 1, which is going to be the same as the one up above, so 17/5 times 7. Again, no common factor. 17 times 17, well, let's see, that's 49. I'm going to multiply these two. Carry the 4, that's 7, 119. I believe 9, 4, yes. And over 5, and, ooh, this is going to get huge. Well, we need 23. So the easiest way is to find out what happens if we just take 23, multiply it by 5. We get 15, carry the 1, 10, that equals 115. We're going to have 4 left over, fifths. As you can see, look at that. That is going to work out. You are a winner, my friend. Letra B. You are in. Thank you, letter B. Now we come here and it says Kayla walks 34 miles in 10 days. Thank you. Finally, one that's reasonable. Because here we could just multiply it by a power of 10. So 17/5, which is what is the fraction we've been using, by 10 is just 170 over 5. And is 34 times 5 going to give us to the 170? I don't know. What do you think? 20, carry the 2, 15? It does. So you're also a winner. Yes. How about Kayla walks 102 and 2/5 miles in 31 days? Ooh, could they make this any more challenging? I'm almost kind of wanting to take a shortcut. Nothing wrong with that. If we can find a shortcut, let's just do 30 days, because that would be easier to solve. Times the 17 over 5. Because here, 17 times 3, that's kind of nice. That's 51, in case you didn't know, plus the power of 10. Now you have 510 over 5. I know I did that kind of quickly, but that's basically was just a quick way for us to do that. Now you can see by 5 going into 510. Well, 5, if I take 500 times, or 5 times 100, I would get 500. Okay? And that would be 5, but that would only be 100. If I did 2 more, that would even make it, this would really be 510. Now that's 510. Well, that's going to be that already, and we still have 2/5. So we still have more. So that's not going to work. And we use 30 days, not 31 days. So yeah, that's not going to work. Nope. So letter D is not correct because she would actually walk farther than that, than the 102 and 2/5 miles. She'd probably about 104 or somewhere in there. Okay, this is kind of like the end, and I get really sad because, the video is coming to a close, and, I want to keep it going forever, but I have to come to an end. So, with not much more being said, my friends, live long and prosper.